All right, in this video, these are just some additional problems for section 5.2 dealing with integration by substitution. Hopefully that these problems that I do on this video will assist you with some of the homework problems that are in my math lab. Okay, it's just a continuation of section 5.2. I'm just providing additional problems. Like in problem number 1, we want to find the indefinite integral and check the result by differentiating. Let's say in this case here we have the integral of 2x times the quantity x squared plus 6, and it's raised to the 6th power. Okay. All right, so in this case here, we can use an appropriate u substitution, and I'll do that by letting u be what's inside the parentheses here, which is in this case x squared plus 6. Okay, and then we take du, the derivative of u with respect to x. That's just going to be the derivative of x squared will be 2x, and the derivative of 6 is 0. So I have du equaling to 2x, and then we include the dx. Well, if you take a look at that, you'll see that you already got 2x dx in this problem here. So let me rearrange this as the integral of x squared plus 6, that quantities to the 6th power times 2x dx. So we had that. That's our du right there. So here, this x squared plus 6, that would be u. And then the 2x dx will just be du. So now when we use the substitution, we have the integral of u raised to the 6th times du. And then we can integrate u to the 6th du by increasing the power by 1. So bring over the u, increase the 6 by 1. It'll be u to the 7th divided by the new exponent of 7 plus c. And of course, I'll write this as 1 over 7 times, and I'll do the back substitution, that u was that x squared plus 6, so it'll be 1/7 times x squared plus 6, and that quantity will be to the 7th power. And of course, since it's an indefinite integral, you must include the plus c as your answer. So my final answer there will be 1/7 times x squared plus 6, that quantity is to the 7th power plus c. Now we can check this by doing the derivative of that. And when you do, if I take the derivative with respect to x of 1/7 times x squared plus 6 raised to the 7th plus c, is what you're going to get. I'll bring over the 1/7. The derivative, we bring the power down. We bring down the 7. Copy what's inside the parentheses to the 1 less power times the inside derivative. The derivative of x squared plus 6 will just be 2. Actually, it'll be 2x, not just 2. The derivative of x squared is 2x. So that means here, the 7's divide out, you'll be left with, I'm going to pull the 2x in front, times x squared plus 6 raised to the 6th, which is exactly what I have here. So that means I've integrated that problem correctly. All right, problem number 2, we got e to the 15x times 15 dx. I want to find its indefinite integral and, of course, check the result by differentiating. So in this case here, using an appropriate u substitution, I'm going to let u equal to the exponent for the e. That's the 15x. That would mean du will have to be, the derivative of 15x will just be 15 times dx. So again, we're writing these as differentials. Now we can use the substitution here. that 15 dx is du, 15x is what u will be. So it'll be the integral of e to the u du. And we can easily integrate e to the u du as this, e to the u plus the constant c. And of course, we let u equal 15x, so we do the back substitution, so it'll be e to the 15x plus c. E to the 15x plus c. And we can check that result by differentiating like we did in the last example, or the last problem. The derivative with respect to x of 15 e to the 15x plus c, e to the 15x plus c. Well, the derivative of e to the 15x will be e to the 15x times its inside derivative. The derivative of 15x will just be 15, which is exactly what I have here, e to the x, and then the 15 in parentheses. So that means I've correctly found its integral. All right, problem number 3. Let's say I want to find the indefinite integral. Indefinite integral here. Here I have the integral of 1 divided by 1 plus 2x squared times the 4x dx. So here's what we're going to do here. I'm going to take that denominator of 1 plus 2x squared and let u be equal to that. So I'm going to let u equals to 1 plus 2x squared. And then the derivative of u, du, will be, well, the derivative of 1 is 0. The derivative of 2x squared would be 4x. So du will be equal to 4x dx, which is exactly what I have here, 4x dx. So now I can go ahead and make the easy u substitution here. So here I'm going to have the integral of the 1 in front in the numerator. That 1 plus 2x squared, that's going to be u, so it'll be 1 over u. 4x dx is du. So I have the integral of 1 over u times du. And that would be, if you recall, the integral of 1 over u du, that would be the natural logarithm of the absolute value of u. And then plus c. And then we back substitute the u, replace that with 1 plus x squared. So it'll be ln of the absolute value of 1 plus 2x squared plus c. Now, sometimes they will put that in parentheses because this expression, 1 plus 2x squared, will never be negative. So they might write it like this, ln of, in parentheses, 1 plus 2x squared plus c. Okay. So that's problem number 3. All right. Problem number 4 is this. Let's say I want to find the indefinite integral and check the result by differentiating. Here we got the integral of s to the 4th plus 1, that quantities to the 5th power times s cubed du. All right, so here we can use an appropriate u substitution. So let's start by letting u equal to what's in the parentheses, s to the 4th plus 1. That would mean du would be equal to this. The derivative of s to the 4th would be 4s cubed, and the derivative of 1 is 0. So du then would be 4s cubed ds. Now notice I do have s cubed ds, but I don't have a 4 in front. So what I'm going to do here is come up with an expression where I can substitute s cubed ds into it. So let's get s cubed ds by itself. It's being multiplied by 4. So I'm going to divide both sides by 4. So that means I'm going to have 1/4 du is equal to s cubed ds. So when I do the appropriate substitution, this is what I'm going to have the integral of. S to the 4th plus 1 will be the u, and it's going to be to the 5th power. S cubed ds, that's going to be 1/4 du. Now, since 1/4 is a constant, I can pull the 1/4 out in front of the integral sign. So it'll be 1/4 times the integral of u to the 5th du. Now let's integrate u to the 5th du by raising the power, increasing the power by 1, divided by that new power. So if I add 1 to the 5, it'll be u to the 6, divided by that new exponent of 6, plus c. All right, now 1/4 times 1/6 will be 1/24. Again, numerator times numerator and denominator times denominator. Back substitute the u with that s to the 4th plus 1. And that's going to be raised to the 6 plus c. Now, another way they can write this problem would be this. The final answer would be s to the 4th plus 1, that quantities to the 6th power, all over 24, plus c. Now, of course, we can check by differentiating by doing this. If I take the derivative with respect to x of, I use brackets, s to the 4th plus 1 raised to the 6 over 24, then plus c. This will be this. I'll write this as 1/24, and then bring down the 6, that's the exponent, bring the exponent down, copy over the s to the 4 plus 1 to the 1 less power, which is 5, and then take the inside derivative of s to the 4th plus 1. That would be 4s cubed. All right, now let's do this. I'm going to bring the 1/24, and I'm going to multiply 6 times 4, which is 24, times s to the 4th plus 1 raised to the 5th times s cubed. Notice these 24s divide out. You'll be left with s to the 4th plus 1, that quantities to the 5th power times s cubed. That's exactly what I have here. So that means I've correctly integrated that problem, or that I did the integration correctly. All right, problem number 5 is find the indefinite integral. So here we got x to the 4th times e raised to the x to the 5th. Okay, so now in this case here, using the u substitution, I'm going to let u equal to the exponent for the e. That's going to be x to the 5th. And then du, if I take the derivative of that, that'd be this. Bring the 5 down, copy the x over to the 1 less power. So it'd be 5x to the 4th dx. Well, notice I do have x to the 4th dx, but not the 5. So I'll just go ahead and rearrange this for simplicity. So I'm going to put e to the x to the 5th here, and then x to the 4th dx. But I want this in terms of x to the 4th dx. I'm multiplying it by 5, so I need to divide both sides by 5. So that means I have 1/5 du is equal to x to the 4th dx. Now I can do the substitution here. So I have the integral of e to the, well, x to the 5th we'll let u be x to the fifth, so it'll be e to the u. X to the fourth dx, that's going to be 1/5 du. Well, 1/5 is a constant, so I'll pull the 1/5 out in front, so it'll be 1/5 times the integral of e to the u du. Well, the integral of e to the u du is the simplest one to do. So the integral of e to the u is e to the u, then plus c. Well, that u is equal to x to the fifth, so it'll be 1/5 e raised to the x to the fifth plus c. And that's my final answer there. All right, problem number 6. Again, we're finding the indefinite integral. So here we got the integral of x to the fifth divided by 3 plus 4 x to the 6 dx. So again, using the appropriate u substitution, we're going to let u equal to 3 plus 4x to the 6. And then we can find out what du is going to be. So the derivative of u, the derivative of 3 is 0. The derivative of 4x to the 6 will be, bring the 6 down, multiply by 4, you get 24. Copy the x down to the 1 less power. So it'll be 24x to the fifth dx. But if you look at that problem, you have only x to the fifth dx. So if I want this to be x to the fifth dx, since it's being multiplied by 24, let's divide both sides by 24 in this equation. So I'm going to have 1 over 24 du is equal to x to the fifth dx. So now let's do our substitution here. We know the integral of x to the fifth dx is this 1 over 24 du. That'd be divided by 3 plus 4x to the 6. That's what u is going to be equal to. Now, since 1/24 is a constant, I can pull the 1/24 in front of the integral sign. That'd be the integral of, let's say, 1 over u du. And the integral of 1 over u du, of course, is going to be the natural log of the absolute value of u plus c. So I'm going to have 1/24 times the natural log of the absolute value of u plus c. Now let's do the back substitution. So I have 1/24 times the natural log of that u would be 3 plus 4 x to the 6. And it'll be absolute value there, plus c. And I believe that would be the final answer for that one, because sometimes they may have ln of the 3 plus 4x to the 6 in parentheses instead of the absolute value, because of the fact that 3 plus 4x raised to the 6 will never be negative. Okay. All right, on to problem number 7. Let's say we got the integral of x cubed divided by 2 minus x to the 4th quantity square. And I want to find its integral, using a u substitution. So here I'm going to let u equal to what's inside the parentheses here, that 2 minus x to the 4th. And then du would be this, the derivative of 2 is 0. The derivative of x negative x to the 4th would be a minus 4. Bring down the x to the 1 less power. Then include the dx. So du is equal to negative 4x cubed dx. Well, I do have x cubed and the dx, but not the negative 4. So let's solve for x cubed dx by dividing both sides by -4. So I'm going to have a -1/4 du is equal to x cubed dx. All right, so now let's do the substitution here. Bring down the integral. X cubed dx will be replaced with -1/4 du divided by that 2 minus x to the 4th is what u is, so it'll be u and it's squared. Now let's pull the -1/4 on the outside since it's a constant. So it'll be -1/4 times the integral of that u squared in the denominator. If I take it out of the denominator, write it using negative exponents, it'll be u to the -2 du. So now I'll have -1/4. And in this case, for u to the -2, if I integrate that, I increase the power by 1. So -2 plus 1 will be -1. So it'll be u to the -1 divided by the new exponent of -1. And then plus c. Well, this negative times that negative will be positive. So it'd be 1/4. And then that u was 2 minus x to the -4. So it'd be 2 minus x to the 4th. So it'd be 2 minus x to the 4th raised to the -1 plus c. Now they might want this as an answer as 1 over, and then 2 minus x to the 4th in the denominator to the +1 power plus c. Maybe position the 1 in the center. They might want it either as this or as that. I do check with my math lab about that. All right, take a look at problem number 8. Here we're finding the indefinite integral. And I'm not going to worry about checking the result by differentiating. I'll leave the checkup to you for the sake of time. So here we got the integral of x times the square root of x minus 10 dx. Okay. So using the appropriate u substitution, I'm going to let u equal to what's underneath the radical, x minus 10. Du then will just be, the derivative of x minus 10 would just be 1 dx, or just plain dx, because the derivative of x is 1 and the derivative of minus 10 is 0. So du then will be equal to dx. Well, we got the dx that we can replace with du. X minus 10 can be replaced with the u, but we need something in terms of u to replace the x with. Well, we already said that we let u equals to x minus 10. Let's solve this in terms of x. We're subtracting 10 from the x, so we need to add 10 to both sides. So that means I have x is equal to u plus 10. So this x will be replaced with the u plus 10. So that means the whole integral will be in terms of u. All right, so using the substitution, we have the integral of x, which will be the u plus 10, times the square root of x minus 10, which will be replaced with the u. Dx then will be du. So everything you see is in terms of u. Now the square root of u in exponential form, of course, will be u to the 1/2 power. So I have the integral of u plus 10 times square root of u is u to the 1/2 times du. Because the exponent for the u is the understood 1, the square root, that's your 2, that's your denominator. Use the distributed property. Distribute u to the 1/2 over u plus 10. Here I have the integral of u to the 1 times u to the 1/2. We're multiplying powers of the same base, so we add the exponents here. So if I add 1 plus, in parentheses, 1 divided by 2, close parentheses, and then press the math key, and then select number 1 for fraction, it'll be 3/2. So it'll be u to the 3/2 plus u to the 1/2 times 10 would just be 10 times u to the 1/2 power times du. Now we'll integrate each piece since we have the integral of the sum. That's going to be the sum of their individual integrals. So it'll be the integral of u to the 3/2 du plus, since the 10 is a constant, I'll pull the 10 out in front, so it'll be 10 times the integral of u to the 1/2 du. So when we take the integral of u to the 3/2 power, we increase the power by 1 and divide that by its new exponent. So if I do 3 divided by 2, then plus 1, hit the math key, select number 1, that'd be 5/2. So the u to the 5/2 divided by that new exponent of 5/2 plus 10 times, increase the power by 1. So if I increase 1/2 by 1/2 plus 1 will be 1.5. But of course, that's going to end up being 3/2 as an improper fraction. So it'll be u to the 3/2 over 3/2, and then plus c. Now, let's look at this. The reciprocal of 5/2 will be 2/5 times the u, which is that x minus 10, and that's going to be raised to the 5/2 power, plus the reciprocal of 3/2 is 2/3. So if you take 2/3, multiply it by 10, which is 10 over 1, you'll get 20 over 3. So it'll be 20 over 3 times the u, which is, of course, x minus 10. That's going to be raised to the 3/2 power, plus c. And in this case, I will go no further than that. So the final answer there will be 2/5 times the quantity x minus 10 raised to the 5/2 plus 20 over 3 times the quantity x minus 10 raised to the 3/2 plus c. And we're not going to worry about checking this result for the sake of time. If you want to, you can take the time and differentiate that yourself. Problem number 9. Somewhat similar to problem number 8. We have the integral of x divided by the square root of x plus 2 dx. So we're going to use an appropriate u substitution for this one. So what I'll do here is let u equal to what's underneath the radical, x plus 2. And of course, du then will be just 1 dx, or just dx. The derivative of x is 1, the derivative of 2 is 0. So you'll be left with 1 dx, or just dx. Well, we can substitute the dx with the du, and we can substitute the x plus 2 with the u, but we need something in terms of u so that we can substitute the x with. Well, since u is equal to x plus 2, since we let u equal x plus 2, let's write this in terms of x. We're adding 2. We need to subtract 2 on both sides. So it'll be u minus 2 is equal to x. So now we can substitute that x with the u minus 2 in our integral. So here we got the integral of that x will be the u minus 2 divided by the square root of x, which is u, and then dx, that's du. So that whole integral is in terms of u. Now, the square root of u is u to the 1/2 if I write that in exponential form. So it'll be the integral of u minus 2 divided by u to the 1/2 power du. Now, each term in the numerator will be divided by u to the 1/2 power. So that means this will have the integral of u divided by u to the 1/2 minus 2 divided by u to the 1/2 times du. Now let's simplify each piece. This is like u to the 1 power. When you're dividing powers of the same base, you subtract your exponent. So I'll bring down the u, and I'll subtract 1 minus 1/2. That will leave me with 1/2 minus 2 times. And if I bring that u to the 1/2 power out of the denominator, it would be u to the negative 1/2 times du. And I'll go ahead and add in this extra step here by writing the integral of the difference as the difference of the individual integrals. So it'll be the integral of u to the 1/2 du minus, and I'll pull the 2 out in front of the integral sign. So it'll be 2 times the integral of u to the negative 1/2 du. And then we'll integrate each piece. So in this case here, or each part, we raise the, increase the power by 1, so it'll be 1/2 plus 1, which will be u to the 1.5, or u to the 3/2. So it'll be u to the 3/2 power divided by that 3/2 minus 2 times. Add 1 to the negative 1/2 will be 1/2. So it'll be u to the 1/2 divided by 1/2. And then plus c. All right, now let's simplify this a bit. The reciprocal of 3/2 will be 2/3 times the u, which is x plus 2. So the x plus 2 raised to the 3/2 power minus. The reciprocal of 1/2 will be 2, but we got that 2 in front. So the reciprocal of 1/2 is 2, so 2 times 2 would be 4. So this will be 4 times that u, of course, is x plus 2 raised to the 1/2 plus c. And here I will go no further than that. Okay. All right, problem number 10. Problem number 10. Here we're going to evaluate the following integral. Here we have the integral of x plus 4 divided by x squared plus 8x plus 25 dx. So if we're using the appropriate u substitution here, okay. So here we're going to let u equal to the denominator, which is in this case x squared plus 8x plus 25. That would mean du in this case will have to be this. If I take the derivative of x squared, that's going to be 2x. And the derivative of 8x would be 8. The derivative of 25 would be 0. So this will be 2x plus 8 dx for our du. Well, if you look at the problem here, you got x plus 4 times dx. I can rewrite that 2x plus 8 dx by taking out a common factor of 2. So here du will be equal to 2. If I factor out the 2, 2x divided by 2 would just be x, plus 8 divided by 2 will be 4. So I have 2 times the quantity x plus 4 dx for my du. Now you see I have x plus 4 dx. I can write this by getting x plus 4 dx by itself by dividing both sides by 2. So that means I have 1/2 du is equal to the quantity of x plus 4 dx. Now we can do the appropriate substitution here. That x plus 4 dx, I'll bring the integral sign over, x plus 4 dx will be replaced with 1/2 du. All that's over. X squared plus 8x plus 25, that's what u will be. Now, notice I can pull the 1/2 on the outside since it's a constant, so it'll be 1/2 times, I'll say 1 over u du. And in this case, the integral of 1 over u du will be the natural log of the absolute value of u plus c. So I'll have the 1/2 integral of 1 over u will be the natural log of the absolute value of u, and then plus c. And then replace the u, in this case, with that x squared plus 8x plus 25. So I have 1/2 the natural log of x squared plus 8x plus 25, and then plus c. Now, in this case, this will never, that 8x squared, that x squared plus 8x plus 25, that will never become a negative number. So in this case here, I can write that using parentheses. So it'd be 1/2 the natural logarithm of, and in parentheses, x squared plus 8x plus 25, and then plus c. Now keep in mind, these two are both correct, but sometimes they might want this or they might want this as an answer, because of the fact that 8x squared plus 8x plus 25 won't be negative. Okay, so that's problem number 10. Number 11. The indefinite integral can be found in more than one way. First, use the substitution method to find the indefinite integral, then find it without using substitution. Check that your answers are equivalent. All right, so here we got the integral of 9x to the 8th times the quantity x to the 9th minus 10 dx. All right, so let's start by using substitution. Then I'll show you how it's done without using substitution. When we use substitution, in this case, I'm going to let u equal to what's in the parentheses here, x to the 9th minus 10. And then find du. So here du then would be equal to, the derivative of x to the 9th would be 9x to the 8th. The derivative of minus 10 would be 0. So du will be equal to 9x to the 8th dx. And that's exactly what I have here, 9x to the 8th dx. Okay, so let me go ahead and copy this over. And this, and another way of writing that would be x to the 9th minus 10 times 9x to the 8th dx. You can see here I can do the appropriate substitution. That x to the 9th minus 10 would be u, so it'd be the integral of u times 9x to the 8th dx, that is du. So here I got the integral of u times du. And then this is u to the understood 1, so I need to increase the power by 1. So 1 plus 1 would be 2, so it'd be u squared divided by that new exponent of 2 plus c. So that means I'm going to have 1/2 times u, in this case, was x to the 9th minus 10. And that's going to be squared plus c. So that's using substitution. Now let's try it without using the substitution. So this is without substitution. Now, the integral of 9x to the 8th times x to the 9th minus 10 dx. If I distribute that 9x to the 8th over the x to the 9th minus 10, this is what I have. 9x to the 8th times x to the 9th would be 9x to the 17th power. Again, I'm multiplying powers of the same base, so I add my exponents here. And then minus 9x to the 8th times 10 times the minus 10 would be minus 90x to the 8th times dx. And then we'll integrate each piece here. I'm going to pull the 9 in front of the integral sign, so I have 9 times the integral of x to the 17th dx minus, and I'll pull the 90 in front of the integral of x to the 8th dx. So here I'm going to increase the power by 1, divide that by the new exponent. So if I increase this by 1, 1 plus 17 will be 18. So it'll be not x to the 18th power divided by 18 minus 90 times, increase that 8 by 1. 8 plus 1 will be 9 divided by the new exponent of 9, and then plus c. Now, if I simplify this a bit, 9 over 18, if I reduce that, that'll be 1/2. So it'll be 1/2 x to the 18th minus 90 divided by 9 will be 10. So it'll be 10 x to the 9th plus c. Well, it's kind of obvious that they're not going to be equivalent here. But notice here that 1/2 x to the 9th minus 10 quantity squared plus c. If I was to expand that by using multiplication, okay, this is what I have. 1/2 times x to the 9th minus 10, and that's quantity squared plus c. This is what I'm going to do. 1/2. That x to the 9th minus 10 is used as a factor twice. So I'll write x to the 9th minus 10 twice. And then plus c. Use the FOIL method inside that bracket. So it'll be x to the 9th times x to the 9th will be x to the 18th. The outer x to the 9th times 10 will be minus 10x to the 9th. The inner minus 10 times x to the 9th will be again minus 10 x to the 9th plus 10 times 10, that's 100. Then plus c. Then if I distribute the 1/2 over everything in the parentheses, this is what I have. 1/2 times x to the 18th will be 1/2 x to the 18th minus 1/2 of 10 x to the 9th will be 5x to the 9th minus 1/2 of 10x to the 9th, again 5x to the 9th minus 5x to the 9th, and then plus 1/2 of 100 will be 50, then plus c. Combined like terms, I have 1/2 x to the 18th minus 5x to the 9th, and another minus 5x to the 9th will be minus 10 x to the 9th plus 50 plus c. Compare this expression with this expression up here. They're almost the same. But the only thing that's different here is that plus 50. So here we can say that the answer found by the substitution approach differs by a constant, which is in this case 50. So I say here that the answer found by substitution differs by a constant. In this case, that constant is 50. Okay. Okay, problem number 12. So we've got the integral of this, the integral of r to the 5th times the quantity r7 plus r to the 6th raised to the 7th power. So again, we can use an appropriate substitution here by letting the u equal to what's inside this parentheses, 7 plus r raised to the 6, or 7 plus r to the 6. And then du would be this. The derivative of 7 is 0. The derivative of r to the 6 would be 6r to the 5th times dr. Well, we do have an r to the 5th in dr, but we don't have the 6. But let's write this by getting r to the 5th dr by itself. It's being multiplied by 6, so we need to divide both sides by 6. So it'd be r to the 5th dr equaling to 1/6 du. Then we use our substitution here. That 7 plus r to the 6, that's your u, so it'll be u raised to the 7th. R to the 5th dr is 1/6 du. And that 1/6 is a constant, so I can pull the 1/6 out in front. So it'll be 1/6 times the integral of u to the 7th du. So in this case, you'll bring down the 1/6. Then u to the 7th, if I integrate that, that means I need to increase the power by 1. So it'll be u to the 8th divided by the new exponent of 8 plus c. Now, 1/6 times 1/8 will be 1/48 times the u. I'll replace that with the 7 plus r to the 6. That's raised to the 7th plus c. Now, they might want this as an answer as well. 7 plus r to the 6 raised to the 7. And the whole thing is divided by 48. And then plus c. Okay. All right, problem number 13. Say I want to find the indefinite integral here. So in this case, I have the integral of x times the square root of 10 minus x squared dx. So again, we can use an appropriate u substitution here. So let's let u equals to what's underneath that radical, 10 minus x squared. That would be a good appropriate substitution for that. And then, of course, du is this, the derivative of 10 is 0. The derivative of minus x squared would be negative 2x dx. Well, we got the x dx, so let's try to get x dx by itself here. We're multiplying it by negative 2, so let's divide both sides of this equation by negative 2. So I'm going to have a negative 1/2 du equaling to x dx. So now I can use that negative 1/2 du as a substitution for x dx. Okay, so let's see. If I rewrote this as the square root of 10 minus x squared times x dx, you can see here that the 10 minus x squared will be replaced with a u. So it'll be the integral of the square root of u, and then x dx will be replaced with negative 1/2 times du. Now that negative 1/2 is a constant, so I'll put negative 1/2 in front times the integral of that u, the square root of u, I can write that in exponential form as u to the 1/2 power times du. Now let's go ahead and do the integration here. Bring down the negative 1/2. For the u to the 1/2, I'm going to increase the power by 1. So it'll be u to the 1/2 plus 1, which would be u to the 3/2, divided by that exponent of 3/2 plus c. Now the reciprocal of 3/2 is going to be 2/3. So I'm going to have I'm going to do this off to the side. 1/2 times 2/3. You're going to see the 2's divide out. You'll be left with -1/3. So it'll be -1/3. And that u will be back substituted with 10 minus x squared raised to the 3/2 plus c. Okay. All right, problem number 14. Problem number 14. In this case here, we're finding the indefinite interval again. The integral of x divided by the square root of 7x squared plus 4 times dx. So just like we did, just like we did in problem number 13, we can just let u be what's underneath that radical. So we're going to let u equal the 7x squared plus 4. I'm just taking what's underneath that radical and let that be u. And then du then would be this, the derivative of 7x squared would be 14x. The derivative of plus 4 is 0. So I have du is equal to 14x dx. Now I do have the x dx, so let's solve for x dx here by dividing both sides of this equation by 14. So it'll be 1/14 times du is equal to x times dx. So here, this is where the substitution comes in. So this would be the integral of x dx will be that 1/14 du divided by the square root of 7x squared plus 4 will be replaced with the u. So this is why I have 1/14 du divided by u as this integral. That 1/14 is a constant, so I'll pull the 1/14 out in front. So this will be 1/14 times the integral of. Now, the square root of u in its exponential form will be u to the 1/2. But when I pull it out of the denominator, it will be u to the -1/2 times du. So keep in mind, the square root of u in exponential form is u to the 1/2 power. But it's in the denominator, so I'm taking it out. It would be u to the -1/2. And now, we're going to integrate by increasing the power by 1 and dividing it by the new exponent. So I'm going to have 1/14 times u to the -1/2 plus 1 will be 1/2. That'll be divided by 1/2 plus c. Now the reciprocal of 1/2 is 2. So it'll be 2 times 1/14. And the 2 goes into 14 7 times. So it'll be 1/7. And 2 goes into self 1 times. So I'll be left with 1/7 times u, in this case, is that 7x squared plus 4 raised to the 1/2 power plus c. All right. All right, problem number 15. We're going to make an appropriate substitution, finding the integral of e to the x divided by 7 plus 4e to the x dx. So I'm going to let u be what's in that denominator. And that's the 7 plus 4 e to the x. That way we can find out what du is. Well, the derivative of 7 is 0. The derivative of 4e to the x, I just bring the 4 down. The derivative of e to the x is e to the x. And then dx. So for So for du, I have 4e to the x dx. Well, I just had the e to the x dx up here. So if I want to find out what the substitution is, I'll just get e to the x dx by itself by dividing both sides by 4. So that means e to the x dx is equal to 1/4 du. Now we can make our appropriate u substitution here. E to the x dx, I'll bring the integral sign over. E to the x dx is 1/4 du divided by 7 plus 4e to the dx, e to the x. 7 plus 4e to the x would be that u. Now, the 1/4 is a constant. I can pull the 1/4 out. So it'll be 1/4 times the integral of 1 over u du. And of course, the integral of 1 over u du would be the natural log of the absolute value of u. So I have 1/4 times the natural log of the absolute value of u. And of course, I need to include the plus c. And doing the back substitution will be 1/4 ln of 7 plus e to the 4x is what u is. So it'll be absolute value of 7 plus 4 e to the x plus c. Now we'll go no further than that. So that would be the final answer to that problem. Okay. In problem number 16, we're going to do an application problem related to integration by substitution. It says here the marginal price for a weekly demand of X bottles of shampoo in a drugstore is given by the function shown below. Find the price demand equation if the weekly demand is 150 when the price of a bottle of shampoo is $2. And then what is the weekly demand when the price is $4.50? Okay, so here we have p prime of x is equal to negative 900 divided by the quantity 3x plus 50 squared. So to find out what that price demand equation is, which is of course p of x, that's going to be the integral of p prime of x dx. And let me make this p lowercase. So that means I have the integral of p prime of x is that negative 900. I can do this without the parentheses. Negative 9,000 divided by, and in parentheses here, 3x plus 50 quantity squared dx. So here we're going to need to use an appropriate u substitution here. So in this case, I'm going to let u equal to what's inside the parentheses, that 3x plus 50. And then du then would just be 3 dx. Derivative of 3x is 3. The derivative of 50 is 0. Notice I can do this. I can pull the negative 9,000 out in front. But if I want this to be dx, I'm multiplying it by 3, so let's divide both sides by 3. So that means 1/3 du is equal to dx. Now let's go ahead and do the appropriate substitution. That dx, I'm going to replace that with negative 1/3 du divided by the 3x plus 50. I'll let u be equal to that, so it'll be u squared in the denominator. And that should not be negative 1/3. So let me get rid of that negative sign. dx, I'm replacing it with 1/3 du, not negative 1/3 du. Okay. Now I can pull the 1/3 out in front of the 9,000. But I can go ahead and multiply 1/3 times negative 9,000. That would give me negative 3,000. times the integral of, let me pull the u squared out of the denominator as u to the negative 2 du. Then increase the power by 1 and divide by that new exponent when I integrate this. So let me bring over negative 3,000 times negative 2 plus 1 will be negative 1. So it'll be u to the negative 1 divided by negative 1. And we're dealing with an indefinite integral, so we need to include the plus c. Now, the negative divided by this negative will be positive. So this will be 3,000 times the u to the negative 1 power. I can write that as 1 over u to the positive 1. So it'll be 1 over u plus c. So here I'm going to have 3,000 over that u. I'm going to back substitute with that 3x plus 50. And then plus c. So the price demand equation, well, in general will be P of x is equal to 3,000 divided by 3x plus 50 plus c. Now I'm going to bring down P of x. Now the problem does say we need to find that price demand equation if the weekly demand is $150 when the price of a bottle of shampoo is $2. So that means here, this is, I'm just separating this, X will be 150 bottles, because X represents the number of bottles of shampoo, and the price, lowercase p of X, is $2. So we're going to take this and just replace P of X with 2 and X with 150. So P of X would be 2 equals to 3,000 divided by 3 times X, which is 2, plus 50. And then plus C, because we need to find out what C is. I have 3,000 in the numerator, so 2 is equal to 3,000. 3 times 2 is 6. 6 plus, I'm sorry. X is 150. Made a big mistake there. That should be 3 times X, which is 150, plus 50. Then 3 times 150 will be 450, plus the 50 will be 500. So I have 3,000 over 500 and then plus C. So 2 is equal to 3,000 divided by 500 will be 6. So it'll be 2 is equal to 6 plus C. Subtract 6, you'll get C to be equal to negative 4. So replacing the C in this function with negative 4, I'm going to have my price demand equation of P of X is equal to 3,000 divided by 3x plus 50 plus negative 4 is the same as saying minus 4. So that's my price demand equation when the weekly demand is 150 when the price of a bottle of shampoo is $2. This will be the function. Now the other part is, what is the weekly demand when the price is $4.50? So now we know P of X is equal to $4.50. What would be the weekly demand? So we're going to use this P of X formula that we came up with. Replace the P of X with $4.50. So it'll be 4.50 equaling to 3,000 divided by 3x plus 50 minus 4. And it would be much easier to just add 4 to both sides of this equation. So that means 4 plus 450 will be 850. 8.50 is equal to 3,000 divided by 3x plus 50. And you know what? I'm going to put 8.50 over 1 and do cross multiplication here. So that means 1 times 3,000 would be 3,000. And that's equal to, if I do 850, and I'll write this out, 8.50 times the quantity 3x plus 50, and then distribute $8.50. 8.50 times 3 will be 25.50x plus 8.50 times 50 will be 425. And then to get the x by itself, I'll first subtract 425 on both sides. So that means I'm going to have 2,575 on this side, and that's equal to 25.50x. And then divide both sides by 25.50. This will be x is equal to, now use the calculator for this one, just to show you. 2575 divided by 25.50. You'll get this number. But then let me tell you, in the homework for this particular problem, I'm just giving you a heads up on this one. They're going to ask you to round down on this one. For the price demand equation, they're going to ask you to round down to the nearest whole number. Not round up, we're rounding down. So this answer will be actually 100. And I'm going to put in parentheses, rounded down. Okay. That would be the weekly demand when the price is $4.50 for that particular problem. Okay. All right, problem number 17. An automobile company is ready to introduce a new line of cars through a national sales campaign. After test marking the line in a carefully selected city, the marketing research department estimates that the sales in millions of dollars will increase as the monthly rate of the following function for T months after the campaign has started. So here we have S prime of T is equal to 17 minus 14E to the negative 0.1 T. And this is where T is going to be the number of months between 0 and 24. So in part A, they asked this, what will be the total sales S of T, T months after the beginning of the national sales campaign if we assume no sales at the beginning of the campaign? Then part B, what are the estimated total sales for the first eight months of the campaign? And then part C, when will the estimated total sales reach $110 billion? Use a graphing calculator to approximate the solution to the equation S of T equaling to 110. Let's start with part A, finding out what the total sales would be T months after the beginning of the national sales campaign if we assume no sales at the beginning of the campaign. All right, so in part A, we're finding S of T, which is, of course, the integral of S prime of T dt. And S prime of T was 17 minus 14 e to the negative 0.1 T dt. So in this case here, if I integrate each part, since I have a minus sign there, I can write this as the integral of 17 dt minus, now pull the 14 out in front of the integral of e to the negative 0.1 T dt. This part right here, I need to do a U substitution. So for this, I'm letting U equaling to that exponent for E. negative 0.1 t. And then du then would be equal to, the derivative of that would be negative 0.1 dt. And then I'm going to get dt by itself by dividing both sides by negative 0.1. So that means dt then will be just du divided by negative 0.1. Okay. This first part, the integral is 17t dt. I'll go ahead and pull the 17 out in front. So it'll be 17 times the integral of dt minus 14 times the integral of u is equal to negative 0.1. So it'll be e to the u times dt, which is du over negative 0.1. Now, I'll go ahead and do the integral of the integral of dt. Bring down to 17, the integral of dt would just be t minus, now for this part right here, if I do 14 divided by if I do minus 14 divided by negative 0.1, it will be a plus 140. You do that on the calculator yourself. 14 divided by 0.1 and negative divided by negative will be plus. And then this will be the integral of e to the u du. But of course, the integral of e to the u would be e to the u. So be just e to the u and then plus c. So here I got 17t times 140 e to the u plus c. Now I need to do the back substitution by replacing the u with a negative 0.1 t. So the whole thing will be in terms of t. So it'll be 17t plus 140 e to the negative 0.1 t plus c. Now that's just for the general equation for S of t. Now, we're told that if we assume that no sales at the beginning of the campaign, we need to find out what would be the total sales. So that means in this case here, if there were no sales, that means S of 0 will have to be equal to 0. That means, in other words, if t is 0, then S of t has to be equal to 0. All right. So I'm going to substitute the S of t with 0. So this will be 0 is equal to, and we're going to replace each t in this function with 0. So it'll be 17 times 0 plus 140 e to the negative 0.1 times 0 plus c. Well, 17 times 0 is 0. Now, negative 1 times 0 is 0, but e to the power of 0 is 1. 1 times 140 will be a plus 140 plus c. Now, of course, if you want to do this in the calculator, if you doubt that, you can do 140, and then for the e second, ln for the e, negative 0.1 times 0 does give you 140. All right. So here I have 0 is equal to 140 plus c. If I subtract 40, bring the 140 over to the other side to get c by itself, your c will have to be negative 140. So that means S of t would be 17t plus 140 e to the negative 0.1 t minus 140. Because I'm replacing the c up here with that minus 140. So this represents the total sales T months after the beginning of the national sales campaign if we assume no sales at the beginning of the campaign. That's part A. Now for part B. I'm going to pull this down a bit. What are the estimated total sales for the first 8 months of the campaign? All right, so this time in part B, and I'll do this over here, T is equal to 8. And we're going to take this function, substitute each t with 8. So S of 8 is equal to this, 17 times t, which is 8, plus 140 e to the negative 0.1 times t, which is 8, minus 140. Now, all of this I'm going to put in the calculator. So here I'm going to have 17 times 8, and then plus 140 for the e second ln, and then negative 0.1 times 8. Then I'm going to use my right arrow key to get out of the exponential part, minus 140. Okay. Now, this is going to be, of course, in millions of dollars as indicated in the problem. So if I round this off to the nearest whole number, then in this case, it would be approximately 59. And it's going to be in $1,000,000. So in this case here, the estimated total sales for the first 8 months of the campaign will be $59 million approximately. All right, now, part C. This is where you're going to need to use a graphing calculator because you're not going to be able to solve this problem algebraically. When will the estimated total sales reach $110 million? Use the graphing calculator to approximate the solution to the equation S of t is equal to 110. So S of t is going to be 110. So that means I'm going to be taking this equation down here, replace S of t with 110. So I'm going to have 110 here that's equal to 17t plus 140 e to the negative 0.1t minus 140. Okay. So this is why you're going to need your graphing calculator for this one, because I'm going to tell you this. This you're not going to be able to do algebraically. I'm going to put this in y1, and the 110 will go into y2. I'm going to show you. So using my graphing calculator, I'm going to go to y equal 2. I'm going to clear all these equations that are in y1 and y2. The part that's on the right, the exponential equation on the right side, I will put this in the calculator. And I'm going to be using x's instead of t's. So it'll be 17, and then press your xt theta n button for the x, plus 140. Then for the e would be second ln for the e, negative 0.1. Press your xt theta n for the x. Use your right arrow key to get out of it, the exponential part, then minus 140. That goes in y1. Now I'm going to go down, use my down arrow key to go to y2, and then I'm going to enter in y2, 110. Now, the next thing I'm going to do is set the window. Here's what I'm going to do. For the x window, it's going to be from negative 50 to 50 in increments of 10. So if you press this window key up here, your x-min would be negative 50. Go down to x max, it would be 50. Then x scale would be 10. Now, for the y, I'm going to give you this here. From negative 50 to 150 in increments of 10. So for the y min, it'll be negative 50. Y max will be 150. Your y scale will be 10. All right. Next, I'm going to press the button that says graph. The first graph you should see is a graph of a parabola. It looks like a parabola. The next graph is going to be a straight line, y equal 110. So you can see that this horizontal line is crossing this graph at two different places. So we need to find out what the intersection is here. That will tell us what T is. So our graph is intersecting in two different places. All right. Let's find out what the point of intersection is on this left-hand side of this graph for this first point here. So to do that, you want to press second and calculate, or second trace to go to the calculate menu. You want to find the intersection. So here we're going to go down to number 5 for intersection and then press enter. And you should get something that says first curve. So the first thing I do here is position that cursor, that blinking cursor, on the point of intersection or get it close to it. And then after that, I'm going to press enter 3 times. 1, then 2, then 3. That will tell me the point of intersection here and the x value and the y value. We're only dealing with the x value, but in this case, we're dealing with t here. Here, our x is going to be negative 11.6. Actually, negative 11.62, I believe. Yeah. Now, for my other point of intersection, which is the one on the right-hand side, I'll do the same thing. Second and trace for the calculate menu. I'll select number 5 for intersection. Oops. Let me quit here. All right. Second and trace, then select number 5, and then you're going to press enter. Now I'm going to position the cursor using my right arrow key to the other point of intersection that's on the right-hand side. And then press enter 3 times. 1, 2, 3. And you'll see it's approximately 12.30 if I round to 2 decimal places. However, we have to eliminate the one that gave us a negative amount because we can't have time to be negative. So that's out. We cross out the negative part there. So that means here that the time will have to be 12.3. That's going to be, that would be when will the estimated total sales reach $110 million. It would be approximately 12.3 months. Let's keep in mind time can't be negative, so that's why I eliminated the negative 11.62. Okay, again, go over this video to get an idea of how to do this in the graphing calculator. Okay, all right, here's the final problem in this video. A yeast culture is growing at a rate of W prime of T is equaling to 0.3 e to the 0.1 T grams per hour. If the starting culture weighs 3 grams, what will be the weight of the culture, W or T, after T hours and after 4 hours? So in this case here, we're going to find out what W of T is. And that's equal to finding the integral of W prime of T times dt. Because we're given the derivative, we want to find out what the antiderivative is, or the integral of this. So W of T will be the integral of W prime of T dt. And W prime of T is 0.3 times e to the 0.1 T dt. And what I will do here is put that 0.3 in front of the integral, so it'll be 0.3 times the integral of e to the 0.1 T dt. And doing a u substitution, I'm going to let u equal to 0.1 T. That's the exponent of e. Then du then will be equal to 0.1 dt. Well, to get dt by itself, I need to divide both sides by 0.1. So that means that du over 0.1 will be equal to just dt. Then we can do our substitution here. So 0.3 times the integral of e to the 0.1t is what u will be equal to. dt will be that du over 0.1. Now, if I do 0.3 divided by 0.1 in the calculator, quit. 0.3 divided by 0.1, that would give me 3. So this will be 3 times the integral of e to the u du. And of course, the integral of e to the u is e to the u, so I have 3 times e to the u plus c. Okay, so let me write w of t, and then back substitute that u with the 0.1t. So the w of t equaling to 3 times e to the 0.1t plus c. Now the starting culture weighed 3 grams. So that means that w of 0 started off as 3. So we're going to replace that w of t with 3. So be 3 is equal to 3 e to the 0.1 t plus c. Oh, t is 0, I'm sorry. That makes it simple. So that means this is your t right here. If t is 0, then w of t will be equal to 3. So it'll be 0.1 times 0. Okay. 0.1 times 0 is 0, so it'll be 3 e to the 0 plus c. And e to the 0 is 1. E to the 0 is 1 times the 3 in front would be 3, so it'll be 3 is equal to 3 plus c. And if we subtract 3 on both sides, that means c must be equal to 0. So in this case here, and I'll write this up to the side, that w of t would be equal to 3 e to the 0.1 t plus 0, but we don't need to write the plus 0 there. Okay. So this right here, after t hours, w of t will be equal to 3 e to the 0.1 t. Now, what about after 4 hours? So that means t is going to be equal to 4. And we just substitute each t with 4. So it'll be w of 4 equaling to 3 e to the 0.1 times 4. And this I can go ahead and type in the calculator myself to get the answer. So it'll be 3, and then second ln for the e, 0.1 times 4. Hit enter. And if we were to round that off to 2 decimal places, that would be approximately 4.48. And they're asking for what would be the weight of the culture. So that means in grams, they're giving this to us in grams, so it'll be 4.8 grams after 4 hours. Okay, so hopefully this will assist you with completing some of the homework problems in section 5.2 dealing with integration by substitution. I do realize that this was a lengthy video, so, kind of fast forward if you need to get to the problem that you need. Also, reach out to me if you have any questions about anything that was presented in this video or any of the homework problems that are in my math lab on section 5.2.